Uh, we did the combined exercise lab last week, so because of that, we have a little bit delay of the schedule. So today we are going to cover the enhanced entity relationship that's supposed to be discussed last week, but I don't think it will take time. So we will finish the chapter 4. And then followed by the chapter 5, that is the main topic today. This week, actually, the database exercise lab for Gcp was scheduled, but as I announced this year, I'd like to introduce both the Gcp and AWS. So to focus on the AWS, I think that you guys can do the the GCP lab by following the description. Okay, if you have any question, you can contact the DBA. Last time, when you connect the MySQL database from the cloud shell, so we failed to connect. But you can use the gcloud, the shell command. This is provided. It's not the general command in the Linux operating system, but this is the kind of the GCP specific the command. Because the cloud shell and the virtual machine MySQL instance are in the same GCP cloud platform, so you can use the gcloud command, SQL, and connect the databases. So I send a link to you guys through the Canvas message. Why don't you try? Only from within the GCP. Otherwise, if you connect your MySQL from your laptop, you need to connect using the MySQL. Also, if you download the GCP Sdk, okay, so you can download the GCP the SDK, so you can use the gcloud command on your laptop. Okay, so later the DBR will introduce how to create the Django and the Python app engine. At that time, you guys need to install the SDK and create the web server on your laptop, then deploy it to the GCP. Okay, so why don't you try to connect to your MySQL database? There are a bunch of different ways. Okay, then hopefully you guys can do the GCP lab. This is not required, but I strongly suggest to create the virtual machine and something other later. When we are doing the database exercise lab, for pretty much the last one, at the time we can create the app server using the app engine, using Python and Django. So if you are not familiar with such the Django application server and the Python, we are not going to teach details of how to use a Python and such a application server. So it's a good time to practice. Okay, know about such a thing. Then we can focus on how to set up and how to create the Django project with the app engine, then to connect the database, so then you can deploy. Then that is a kind of one example of your project. Also, today, the last week is the due date of the project phase 1. I think the one team didn't submit. You submitted the phase 1? What's the last week due date? If you didn't submit the phase 1, please email to the DBR directly, because the Canvas, the assignment is closed. So please contact the GA, the DBR, to submit it. And all other assignment homework, sometimes I couldn't remind you, so you need to check the Canvas message and also our schedule, so to submit on time. So one more time, I already sent out a message just before. We are going to have the AWS, the extra session lab. It's not required. If you already know about the AWS, you don't have to. But if you never used the AWS, or if you know about, if you are interested in the ACF, AWS Cloud Foundation, the certificate, so you can attend this extra session on Friday. It's 9 to 3 o'clock. So first half will be lecture. 20 hours lecture will be shown to the squeeze to the 3 hours. And also after the short break for lunch, we will have the 2 hour, 2.5 hours, the exercise lab. You can see the first exercise lab on the Vocarium if you successfully sign in all the requirements in the AWS lab. So I'm going to enable all the other exercise lab. It's toward the 6th, the exercise lab. So after we may not have enough time to complete each and every lab, so Divya and me will introduce how to do the lab or the. So one of them is creating the MySQL database using the balance and so on. So we will introduce 2 or 3 if time allows the 3. Otherwise 2, mostly 2. Then you guys can complete the other lab at your home. Okay. Then attendance is not required. Pretty much I'm going to assign the AWS assignment to complete all the lab and submit the. Actually, I can see probably. I'm not very familiar with the admin interface, but I'm able to see the activity. So then it will be kind of the exercise like the assignment. So you can attend if you have time. Otherwise, you can do the lab and like reading the lecture. Also, bookshelf. The vital source bookshelf is the PDF file and all the material. So I'm going to use that material for the lecture and the lab. Any question regarding to the any assignment homework? And today is I think the Divya hand out your first in-classroom assignment regarding to the online bookstore, the EI diagram. That will be used for the next in-classroom exercise, in-classroom homework. So please keep, do not throw away to the trash can. Okay, yeah. So we will use the behind. After we finish the other chapter, we will do the relational schema diagram over here. Please keep for your next assignment. Okay. So today we are going to continue for the. Any questions? Right. So, anyone who are interested in the deep learning nowadays? Yes.
I mean, where can we learn about web design? So the first page which we want to create in our.
Which one?
I mean the web page design.
Web page design.
For bidding systems.
Bidding system.
Yes.
That is your job to design whether I'm going to use the web interface, web application, which is the most popular one. But if you want, you can create different application. Like you can using the Java, you can directly connect the database. So you can build a standalone system without using the web application. Web application is not required for our project. Okay, so you need to plan. So if you want to build a standalone system means you create your own application, then the setup to connect the database, then directly connect the database and use the MySQL database as a backend. Okay, but if the most popular one is a web application, so you can create the web server, application server, and I'm going to explain. I'm going to give the more example later. But for example, I direct to use the Django, and then as an application server with the Python program languages, so you can connect the database through that application server. It's kind of 3-tier the architecture. So it's up to you. That's your job to design. Okay. Any other questions? Okay, so then the program language, you don't have to use only the Python. If you are familiar with the Java, or if you like to use the Perl, PHP, so feel free to use. But in this class, we cannot teach and practice all different languages, all different the combination of the architecture. Instead, the Divya will introduce a couple of things. Okay, one is Django but this time we have another. The platform, AWS, so we try, pretty much is limited, but that's your job during the project, how to set up and how to connect the database from your own program language. So Google is much better than me, so you can find it. Especially if you go to their website, like I try to use a PHP. If you go to the PHP, they have all the tutorial to connect the MySQL, Oracle, and so on. So you can figure out and set up and create your application server. Our main focus is not such an application front-end part. Instead, it's a back-end database design and connection. That is the main focus. However, if we definitely page 5, I'm going to grade you the front end also. But the main part is design and creating and connecting your database. That is the main part. Okay? So one time, really, one student create a very fancy, nice application server front end. But when I grade, actually it doesn't use a database. It uses the built-in, the data source. For example, the App Engine, Google, the cloud compute, GCP provide data store. It's a built-in data store. It's not database. It's very similar as the database. It's very simple to store the data, but it's not allowed in here. So you should use the MySQL database, either AWS or the GCP, and create your applications. Okay. We'll see more details. So let's go back to my question again. So anyone who took the machine learning or data mining or the deep learning class before? But everybody know what are they, right? You heard about it. So think about how make the machine learn something. So they can recognize the image. They can recognize that this is a marker, this is a pencil, who you are. It's like the face recognition. How does it work? How does it work? Mostly, its details are different, but mostly it's based on the training. So they try to know the command, the repeated, the feature, characteristic. So think about how the human being learns something. In other words, when you are 2 or 3 years old, probably your mom and dad taught you, right? So like for example, this is the apple. So you can eat. So this is another apple. But if you hold the pen, then probably your parents. So this is not something to eat. So you should not. This is not an apple, like that. So when we learn something, it's kind of the training and repeat the something. So at that time, somebody say it's a two process. The one is, so we have the example of the things. Right? So this is apple, this is apple, this is apple. Your mom taught you this is you can eat, and this is a fruit, the apple, and eventually, so you can generalize this is the kind of apple. Your definition in your mind, right? Then later, when you see the really new apple in a market, you never seen this apple, right? Before in your life, but you know this is an apple, you can eat it. Right? If there is the fake apple, you can recognize. Even though nobody tells before this is an apple, it's a fake apple, but you know this is not a real apple. So you do not eat, right? So at this time, so this kind of process from the example, so we can generalize something definition of the object, right? Not only apple, but a lot of things we can generalize in our process. Sometimes, then, if we have our definition in our mind, in our perception, then we can specialize. Even though we never seen this one, we can specialize. This is an apple based on our experience, our definition. So sometimes you can specialize this fake apple, real apple, try to eat, but this is not. Okay, too much shiny, then you can modify, revise your definition. It's kind of feedback and the training, and then modify your generalization, your definition. Then next time you will select this one as an apple. So somebody said our thinking process is like the combination of generalization and specialization. Have you ever seen this kind of process? This one looks like the what? It's actually object-oriented programming. From the object. So real thing. From the object, what can you do? You can create class, right? So if you remind your OOP class, there are two different objects. One is real object, student object, student object, student object. From the real thing, you can define a class student. Right? Then, in your programming, you can create what? Object in a memory. This object is different from this one. Right? This is a real thing, our life. This one is the object in a computer, especially memory. Okay? This one is called what? Instantiation. You can instantiate, you can create. So this process, generalization and specialization, has been used a lot in our, not only our life, but also in the computer system, computer design. So like the class definition and instantiate the object. So think about go back to the main purpose of the conceptual design. Conceptual design is what? We try to collect and make some important the object from the important thingy, important entity, then grouping and generalize. So kind of grouping to get close to the data structure. Data structure is very strict. It can understand only 0 or 1, not like our human perception. Okay, sometimes it feels so good, but the computer cannot. So computer can understand such a 0 or 1, the binary-based data structure. We try to get close there. So to do that, we have used entity and relationship concept. So we consider the real life, the real object as an entity and their relationship. That's pretty much good. Then we have used for the company database, university database, the online bookstore database. Also, you have chosen one example of your database, the database description, and you should upload by this evening. That's another your homework today. So please do so. So that's pretty much enough. But not all of them are covered that represent such a generalization and specialization. So we are going to extend the ER diagram plus this generalization and specialization is called the EER, extended, or sometimes it's called enhanced ER diagram. Because anyway, conceptual design, ER modeling is, we try to model it. We try to create the model of our daily life, our real life, our information. But this part sometimes cannot be represented by ER, so we will see the EER. So for example, we try to use employee. So one student actually designed the company database, then they realized that there is the engineer, big file of engineer. Then another thing is let me use the engineer, the entity, okay? And then realize there is a technician entity. Then find the secretary entity. 3 entities they find. So it may have something attribute. For example, social security number and the name and engineering type. So that definitely the SSN is the key attribute. And technician, SSN and name, tech type. And for the secretary, SSN and name and typing speed. This is our initial database design with the ER modeling. So entity and their attribute. But we can see the engineer and technician, secretary, all of them are what? It's an employee, right? We can generalize like the employee, even though your customer doesn't mention about the employee, but when you see the data, given the information, tech engineer and technician and secretary, all of them are employee. Why not generalize? Especially attribute, social security number, name, social security number and name, SSN and name. They are common information. It's an employee. So we can create the social security number and name, for example, address also. Can we represent this kind of relationship with the relationship of the ER model? Can we represent like this one? No, because it's like what? Super and subclasses. From the OP concept, from this kind of concept, they belongs to this one. They belongs to this one, belongs to, in general, it's like the employee, but they are specialized, different type of the employee. So we cannot use the relationship because they are in the same employee entity. So instead of using the relationship, we are going to add one more thing that is extended part, what enhanced part. Like this relationship, this is called enhanced or the extended part of the ER diagram. Especially it's called the super and subclasses relationship. Okay, so at that time, so let's see this kind of the ER diagram. How many entities can you find here? Yes?
Can this be applied to the previous case where we had associates and manager?
Mm-hmm.
Can enhanced ER be
So,
used to manager?
Manager is the relationship between employee and what? Department.
Okay.
It's a different entity. But here, engineer and employee, they are actually the employee. But it's a specialized employee. So it's a part of employee. So because of that, we cannot use such a relationship. So here, this one is called super and subclasses relationship. It's not actually a relationship. It's the representation, detailed representation. So, quick question is, how many entity types can you find here? 3?
4.
4?
One.
1?
Many.
Many? It's actually one entity. There's no this kind of relationship. It's a details of one entity. It's an employee entity type. But we are going to specialize or generalize into the 1 or 3. Okay? So it's an engineer, employee, technician, employee, secretary, employee. If you are a little bit confused, so think about in the OP concept, super and subclasses relationship. Okay? It's exactly the same. That means in super and subclasses relationship in OP, what is the characteristic of this one? Inheritance. So it has the same, the characteristic of the inheritance. For example, even though we do not have the key attribute to social security number of the subclass engineer, it actually has the SSN, name, and address automatically. And the social security number, name, and address. And this one. And also, this engineer type is only for subclass engineer. Okay? Employee. This the technician type, the tech level, is only for this the subclass. And typing speed is only for this one. So this kind of the design is called enhanced or the what is that? extended. So name is not important. So EER model. Later, this is another question. What about the relational database later? Can the relational database can use this one? Actually not. So database, relational database, no way to represent such an object-oriented concept. It's a super and subclass. Then we will see how to address. But in the real life, so we have such the detailed, precise relationship. It's a super and subclass or object-oriented concept. But the relational database later, it doesn't represent the OP concept. That is the main problem of the relational database. However, because of that, relational database can handle the consistency of the data. So we will see later. So this is called the EER diagram. Let me use the slide for our example. So this is one example of the EER diagram. Question: how many entities can you find here?
3.
So one is definitely employee. Another one is the project. The third one is trade union. And the hourly employee rate. Hourly employee. Is it the entity or not? It's a part of employee. So what about the secretary, technician, engineer? It's also part of employee. Manager is also part of employee. So you can use this kind of the EER diagram if you want to combine with, for example, this one can be project, this one can be the department, but if you want to create a relationship manager only for the manager, okay, then you can create the super and subclass of the employee for the manager, then create the relationship. Then much more detailed and precise. Okay, so we have the 3 relationship. We have the 3 entities. How many relationships? We have only 2, manage and belongs to. So which means we can create a relationship with the subclass to create the detailed, precise the model. Because if we create a manager with the employee, not all employees are manager, right? So in this case, only manager can have the relationship with the project. Right? Then let's take a look at the employee. So for the employee, how many super and subclasses relationship? How many super and subclasses? 1. We have 1, the secretary, technician, engineer with the employee. You can see that we can combine them with the circle. Okay, we are going to use the circle to represent the subclasses. 1. There is another one, salaried or hourly employee. So 2, super and subclass. What about this one, employee and manager? It's also super and subclass, but how many subclass?
1.
It's just 1. So because of that, we actually eliminate the circle. You can use the circle, but not always. So for in case the 1 subclass. Then there are different notation I don't explain yet. Let me use this diagram to explain. First, what about what about this one? Double line, sometimes double line, sometimes a single line. So do you remember the single line and double line before? Mandatory or optional. Meaning is, so if we have the double line for this, all employees should be one of this at least. Okay? So that's the full participation, mandatory participation. However, what about this one, single line? Optional means there might be employee. None of this. just a general employee or the entry-level employee who are not assigned any of these. Either way is fine. So you can select double line or single line, full or partial, mandatory or optional participation. Another thing is the D. So D, or you can use the O. D means disjoint. O means overlap. So disjoint means, as the word implies, employee should be one of this, only one of this. Okay? When you inherit, only one inheritance. So it's a disjoint. So employee should be one, the engineer, or technician, or secretary. If this one is a single line, just a general employee, none of this. That's a disjoint. On the other hand, overlap means employee can be engineer plus technician. That may be possible. So I'm staff member of university. Also teacher, professor of the class. So I can be multiple role. So multiple subclass. Or all of this. So if you allow overlap, then this one can be O. So there are 4 different cases. Partial. The partial means the optional and the full participation. It's a mandatory. So disjoint with the partial. Partial disjoint. Partial disjoint means single line and D. Which means employee can be general employee or engineer employee or technician employee or secretary employee. None, you do not allow both of them. That is disjoint plus partial. Or disjoint plus the full means we do not allow this double line. So one of this employee. And overlap. Overlap partial means can use O and single line. Meaning is you are going to allow multiple subclasses. And this one or this one. Also, it may be possible just the employee without this subclass. That is overlap and the partial. Overlap with the full means employee should be at least one of this. Multiple, yes, it's okay. And all of that is okay. So using the EER diagram, we can represent more precisely the meaning of the employee entity. So this is called the enhanced or extended ER diagram. So in the database design in the page 2, conceptual design, please consider such a enhanced part. Sometimes you may not have. Like for example, my requirement is engineer, technician, and secretary only. But intentionally, you can create the generalized, the employee. I have only the bidding system. There are the bidder and admin and the other user. So 3 different type user. So you can generalize into one user. Or I have just one user, but you can specialize the 2 or 3. So for your practice, please consider such an extended the ER diagram. Any question? If you understand the OOP concept, this is very simple. Okay, it's a super and subclasses relationship. Then more details. If you want the details of how to classify secretary, technician, and engineer, you can use the one of attribute that is the job type. So if you are using the specific, in this case, the job type attribute to separate the subclass, you can put name of such attribute next to the employee and connect to the disjoint. Then this is a value, secretary of the job type. The technician for the job type, engineer for the job type. Also, I didn't explain about this one. This and this. The meaning is, it's not required, but when you create this ER diagram, this one shows, actually the name of this one is a cup or cap. This one is a cap, this one is cup. For example, if you create this cup, meaning is, when you create the ER diagram, first you identify engineer, technician, and secretary. Then generalize. On the other hand, if you identify the employee first, then specialize. This way you can use the cap to represent how you build the ER diagram. But for database design purpose, we don't need such a thing. Okay? It's for only the conceptual design. So you don't have to worry about too much such a notation, cup and cap. Okay, so we created this one. Another example of the generalization. This is a car and truck. So A is your initial conceptual design for the vehicle. So we have the two entities, car and truck. And we identify the number of attributes of car and number of attributes for the truck. And also we identify the two key attributes for the car, two key attributes for the truck. Okay, then you may realize, so car and truck, both of them are vehicles, and they have the same key attribute, like the vehicle ID and license plate number. Vehicle ID and license plate number. So you can generalize into the vehicle. So you can see it's a disjoint. What? Why? Because we generalize. So generalization meaning is the vehicle should be at least one of these, right? Also, it doesn't allow both car and truck. It's a separate. So that is the reason it's a disjoint with a full participation. So you can understand the meaning of this one from the ER diagram. So we already did 4 different cases that I explained here. If you can understand meaning of this ER diagram, that's pretty much okay. Okay? It's not the really rocket science. It's not very complicated one. So if you understand this, it's totally fine. The problem is in real database design, even not classroom, not the exam, in real database design, first you should know what is the meaning of secretary. Similarly, if you are designing financial database, you need to understand what is the specific terminology and how what is the workflow and how to read the data. So that domain knowledge is mine. Then you can apply such a database design technique. This is another example of the generalization. Why? Because it's the curve is generalized, which means what type of the ER diagram from here? It's the overlap. Full participation and overlap, meaning part should be one of these, right? It's a full participation, at least one of these. It allows overlap, meaning manufactured part or purchased part or manufactured and purchased part. It's an overlap. So that is the meaning of it. What is the social security number of the purchased part? Not social security. Key attribute. What is the key attribute of the purchased part?
Part number.
Here, part number. And what about this one? And does it have the description attribute? The manufactured part has the description? Yes. All attribute of the superclass will inherit to this one. Okay? There are a couple of more the variation of the EER diagram. So first one is the hierarchy. Okay, so hierarchy is the single inheritance, which is the kind of tree structure. Tree structure is the, in your data structure class, you learned about the tree. Tree has the what? Parent and child relationship. The first one is called root node, and the last one is leaf or terminal node. And in between is the internal node. So internal node has both the root and the child. Number of children, no. Okay? How many? The parent node. One parent, one parent, one parent. Okay? That is called the tree structure. That is called also hierarchy. However, if you allow the multiple inheritance, like we have the relationship and also another relationship to the subclass, that is called lattice. Lattice is more generalized, the ER diagram. Okay? So, tree structure that you know is a hierarchy. It's the one simple the inheritance. But if you have the multiple inheritance, that is called the lattice the structure. So we will see the example of the engineering and manager. You can see this is the inheritance, and inheritance. So three of them are inherited. It doesn't have to be the same, the superclass. Eventually this one. Sometimes you can allow different entity for the parent, the superclass. So this is called the lattice. Lattice is a generalized one, but in real example, it's not very popular. The reason is that later our goal is not the OP design. Our goal is create a relational database model. Relational database model. Actually, there is a way, but it's more complicated. So not very popular for the lattice style. So this is one example of the ER modeling for the university, part of university database. Quick question. How many entities can you find? How many? One? One. It's one for person. So it's very complicated, but there is actually the one person entity. Then what can be the key attribute of this entity? Probably SSN. SSN can be used for all of the other. And overall, the ER diagram is what is created, generalization or specialization. Which way? Generalized or specialized? Is the bottom up or top down?
Bottom.
It's the bottom up. So they probably receive the research assistant information, teaching assistant information, separated. Then eventually you realize all of them are person generalized. So it's a generalization process. Okay. Then we will see what about how many super and subclasses the relationship? How many? One, right? And two, and this one is three, and this one is three, and four, and five. So the ER diagram has 5 super and subclasses. Okay? It's an extreme case. In real life, I don't see this kind of example later, but sometimes you need to specialize. If this one is the database for HR, we need to specify the type of employee and so on. We need to use such a case. Okay. Any question for this? If you can understand the meaning of this and explain properly, it's totally fine. Yes?
Can you explain the 5 super and subclass?
So, first one is the person is a superclass, and the employee, alumnus, and student. This is one super and subclass.
Yeah.
We have one. And the employee is a superclass, and staff, faculty, student, assistant. This is the one super and subclass. Then student and student assistant. This is the one. Okay? And the student and graduate student, undergraduate student is a 4. And this one is 5. So we have 5. And also you can see it's a multiple inheritance. This is the lattice case. Okay? So this is an extreme case. There's one more time. You will see this kind of thing later. Let me use this example. In this case, this is a superclass, and this is a subclass. So superclass is a person, superclass, and the bank, superclass, company, superclass. They combine into one. In the previous case, so this one is a multiple inheritance. So from the employee and the student. However, both of them are from the person, same social security number. Okay, person. So they belongs to the same. This inheritance, little bit different, like the employee information, student information. Eventually, it's a person. We can use the one key attribute, social security number. However, sometimes your parents are different. So this example is a full. So when you purchase a car, so how can you purchase a car? If you have a cash, you can pay. So you are the owner of the car. However, not all the people have the cash to pay off. You need to get the loan. So there are different types of loan. You can go to your bank and get the loan without approval. And also, manufacturer provide a financial program. Like the Honda, they have the 0.9, the financial. So you can use such a company loan and bank loan and my own, the cash. Which means 3 different, the owner. Okay? Until you pay off, you are not the owner. So you cannot receive the title. So we have the different types of the superclasses. Okay? Person use the driver license number as a key or social security number. Banker use the bank name as a key. Company use the company name as a key. They are different. So how can we address this one? So at that time, we can create the union of the superclass to inherit to the subclass owner. So this is called the union type. So if you cannot, so I usually do not ask the student to understand the union type, but instead, it's just the different type of the owner. Different type of the owner. But if each type is the entity, in this case it's entity, and entity, they can create their own relationship with other. So this time we can create the union type, which is not very popular, but it can be. So this time, the main problem of using this one is, what is the key attribute of the owner? So we need to create we cannot use the driver license only. We cannot use the bank name only. We cannot use the company name. One option is driver license number plus the B bank name plus the C name. It will be really complicated. So instead, you can create your own additional, extra, the key attribute for the owner that is called the surrogate key or artificial key. So because of that, when you design the database, you create a lot of such a ID, something number, ID. It's called the artificial key. Okay, like the customer never mentioned about the customer ID, but you can create the customer ID for the key. Later we will see why we like such an ID number as a key. So in this case, definitely we need the owner ID instead of combining all 3 entities. So this time, how many entities? This person is an entity, bank is also an entity, company is an entity. It's a different entity. So you should be careful. But it's not critical. Instead, I suggest you guys to understand this one as the type of owner. So it's called the union type. Okay? So this is the last one for the ER diagram. Actually, ER diagram is very similar as the UML diagram. So if you understand the UML diagram, it's very easy to understand. Okay, so then we finish conceptual model. One more remind. This is information. This is our real life. So our goal in this class is to design database using DBMS. This is our database. Okay. So to do that, the first step is we organize the data information to be data. Okay. We design. This is called the conceptual design. For the conceptual design, we use what? ER modeling or EER the model. So there are a bunch of different ways to model the requirement or the information, but we are using ER modeling. As a tool, we can use Arway or any other software for designing tool. Okay, that is the first exercise lab. So then, problem is, can we create the database from this ER diagram? Actually, I think that some of you guys already tried. When you install the ER Orwin software, there's the option to connect the database. Then, if you create the entity, rectangular, automatically create the database. That doesn't mean this one is the same as the database. Instead, there's an in-between. This one is a conceptual level, okay? Which means it's very close to the human perception, not the database. Database uses 0 or 1 combination, binary. But the human being may be different. So to bridge the gap, we need another model that very close to the database system. Okay? This is called the database model. This one is called data model. Okay? We focus only organizing information to make the data. But it's not database. We need another model that is very close to the DBMS, database system. Okay? This one is a database model. Among them, we are going to use relational database model. So today we are going to see such a relational database model. Have you ever seen this photo before? So his name is E.F. Code, Dr. E.F. Code. He was the researcher in the IBM T.J. Watson Center, and actually he's the one his publication, the paper, is a relational model of the data for large shared data banks. So this paper is the most cited. Citation means another paper used, okay, this paper on their reference. So the more times the paper is cited, it's a better paper. So this is the most cited paper in computer science area. So there are some awards following his name, Dr. E.F. Code, and so on. So, but in 1969, there are several things that happen. One is Dr. E.F. Code actually proposed this paper or relational model of the data for the large shared bank data. Another thing is this year is a 50 years anniversary of what? Moon landing. So 1969, who is that? Neil Armstrong landed on the moon. It's July 20 something. It's a 50 years anniversary, so we had a lot of celebration and so on. So another 50-year anniversary of Professor Lee was born. So I have lived 60, 70, 80, 90, 2000, 2010, maybe 2020. It's the 6th decade already. So he proposed this idea 1969. Then the officially published 1970. This paper is the most cited paper. It's worthwhile to read. It's not very difficult. So we pretty much did talk about what he presented in his paper in this classroom. Okay? So his idea is a motivation problem. Actually, the first time the problem was, so at the time, to manage the data had been bigger and bigger at that time. Even still, we struggle with such a big data. We even offer the big data course and big data system. So even at the time, it was the problem. Their data size actually not like the petabyte or exabyte. It's a megabyte. But even megabyte was the big. So if you search the Google, how much expensive the hard disk drive in 1980, so 10 megabyte hard disk drive is 4,000, really, like that. So it was very expensive and it was the problem. So before that, even we had a database. So first database is integrated in one server. We have the computer and the memory and the storage, everything, and data database was part of this system. There was no network connection. Everything is here. Then, if you want to connect the database or this system, you can connect through the dummy terminal. Even no network. So you can use a dummy terminal. It was called the CRT, and even the keyboard is connected to this one. Then you can code and submit the job, and it can be printed out to the operating room like that. So this one is called centralized. The database system centralized into one server. So one big machine. Actually, comparing to our current computer system, it's not that the really big system, but at that time, it's a really big system and centralized. Then they encounter a problem of such a size of data. Size of data is bigger and bigger. So he tried to address that problem. How can he address the problem? His idea is, when we consider the data, if we put the information here, information here, information here, if we use the information as it is, the problem is, even though I have a number of students, his information is he's handsome, nice, and he likes the hip-hop music. That's the information about him. But when I consider the other student, he likes the sports and the other interests. So each and every student are different. As an advisor, I can consider such a thing, but if it is not the same interest, same information, I need to write down the different way, describe. All students are different. How can I manage the 100,000, millions of students? Each of them is different description. It will be complicated. Even when I search such a big file of the student description, who likes the math? I need to read everything. So, if the data is not well organized, which means not standardized, it will be difficult to manage and takes a long time. Same idea. So when Dr. Yev got to consider such a very large shared data, what will be the idea? Standardize. Even though he likes the music, even though he likes the sports or such a athletic, but my standardization is the name, ID, address, and your grade of the math. That's it. So name, ID, grade, and name, ID, grade, name, ID, grade. Even though she likes the TV drama, so I don't care. Okay? So based on our design, especially the conceptual level design, so we collect the important information, then create the entity like that. So when we manage such a data in our database system, so why don't we consider the data as a group? Okay? Not individual, but recently, when we talk about the NoSQL database, it's different story. I will introduce the strategy later. But when he addressed the problem of the big data at that time, he considered standardization. Then how can he standardize? He got the idea of the set. So set theory. Everybody know what is this and what is this, right? Or sometimes we can use x bar x is bigger than the 0 and the x is an integer, like that. Different notation of the set. Okay. Even we have the empty set, or this is the same as this one. So why do we consider the set the beginning of the math? One of the main problem of using the number in a math is infinity. Number is infinity, but our life is not infinity. So we cannot count all the number. 1, 2, 3, 4. Have you ever count all the number? Probably you try. Yeah. So when we cannot go to sleep, we count number, and probably less than 1,000, you go to sleep like that. So human being cannot count all the number. Then how can we use such a number? Even never use the number, never seen the number, we can add. We can the subtract and the multiply. We can log. So how can we do that? Even we never use the number. So mathematicians, they try to address that problem at the time. Instead of counting each and every number, why don't we define? So I is x bar x, this is an integer whole number, okay? Like that. So set actually define such an infinite number. Then as an element of the set, so A belongs to I and B belongs to I. Then we can do A plus B is equal to B plus A. Then we don't have to count it, we don't have to test each and everything. Because number, integer number is standardized by the set. So same idea. He got the idea, really get the idea from this set theory to manage the data. When we talk about the data this is called what in the set theory? Element. So why not? We consider element as one data. For example, Lee, the ID 111 address Bridgeport. Another element is the James 112 and the trombone. Another, the Shiva 113 is a Bridgeport. Like that. One element, another element, another element. Even though we have many students, we can define this one as what? Name, ID, and the CD name. Even though the Lee likes the sports, we don't care. It's not said. However, if that is important for all students, you can include. If you believe the music, favorite music is really important, is required by your customer, you can include such a favorite music. Otherwise, we don't consider. So just standardize using set. Okay? This is very similar as what? Conceptual level modeling. Very similar. So we can define this one is called attribute. Attribute of each element to describe such a data. So at the time, this is called what? Relation. But he tried to use different name. So this one is called relation instead of set. Okay, so actually the relational model comes from the set theory, but he used a different name. It's a relation. So relation, internally is the implicit meaning of the relation is relationship, because he tried to find the relationship of the data, relationship of the element. So, but the name of this one is actually relation. So because of that, this modeling is called relational modeling. Relational database management system. So we are going to define what is a relation. Okay. So this is the example of the database. So database state. You can see there is a student database. So if you remind chapter 1, so our goal is to define the schema, name, social security number, and so on, and also create the instances. So Benjamin Bayer and so on, number of instances. So this is a database state. So when we consider how many data here? 1, 2, 3, 4, 5 elements, 5 data. We have the 5 of them. Okay, 5 of them standardized with this schema: name, social security number, home phone number, address, office number, AC, and GPA. So like this. Okay, at that time, group of attribute is a relation. Group of attribute represent what? This student relation, student set. If you have the number of name, social security number, and GPA, you can explain what is a student. Okay. On the other hand, if we know all possible data, like the 5 data, Benjamin Bayer, Chung-Cha Kim, and the Dick Davidson, the Rohan, and the Barbara, if we have the 1, 2, 3, 4, 5 example, okay, if you remind, there are 2 ways of representation of the set. One is list all elements. Another one is with the condition. Right? You can define the condition of X. You can define what is X. So 2 different notation. Same thing. When we represent the data as a relation, 2 different ways. One is definition of this using attribute schema. Another one is you can list up all possible data. Tuple. Okay. So Benjamin and Kim, Davidson, Hunter, and Benson. You can list up all the data. So definition of the relation is the 2A group of attributes. This is the definition of the relation. Also, a group of data. Sometimes you can use the data, sometimes you can use a tuple. But the EF code uses the name of a tuple to differentiate from the data. Okay? But it's the same meaning, the tuple. And also, or sometimes a row. Rows, 1 row, 2 row. And also sometimes it's a column. So these are the definition, very simple definition for the relation. A group of data, a group of tuple, group of rows, or the group of attribute. You can see the 2 different ways. You can define database as a relation as this way, group of attribute, or group of tuple. Actually, the current database focuses on the group of tuple. The meaning is, so let's say that we have millions of tuples, millions of data, millions of students. Our goal of using this database is to find a specific student. So most of the system actually try to find very fast, efficiently, who lives in this road, who are the Benjamin Bayer, who are the age 19. So our main focus is to find the specific data. However, it is also possible our goal is to find a specific attribute. For example, nowadays IoT is very popular, so we have the simple small device to collect the temperature from the air. So we create the 10,000 sensor that can capture the temperature and send to the system every minute. So 10,000 sensor can be one attribute. Sensor 1, sensor 2, sensor 3, sensor 4, like that. Then they send the temperature every minute. So data from each minute will be one row, second row, third tuple, and so on. Sometimes our goal is to find the area of the temperature is over 80. How can you find the area? From the location of the sensor. Okay? Our goal is to find the specific sensor. Sensor is what? Attribute. So which is called the column-based database. Column-based database. However, as I mentioned, most of the system is the data-driven database. So most of the system try to find the specific row, specific data. However, nowadays there are the system to find the specific column. So the reason is that when Dr. E.F. Code define the relation, this one, it can be column, a group of attribute, group of column, or it can be group of data, group of tuple, group of row. Okay, so this is the definition of the relation. It's a informal definition. Informal definition of the relation is here. After we define the group of data, first thing is each data should have a key. One key to represent its own, the value. So for example, in the student case, we have the student ID. Student ID, student ID. Using this student ID, we can find the specific tuple, specific data. That is called the key of relation. So, when Dr. E.F. Code define the relation and model, first, relation is group of data or group of attribute. In other words, when we create the relation, we need to identify a number of attributes. Then, among the attributes, one attribute should be key attribute. Key is the unique that can represent or that can uniquely identify the specific data. Okay. For example, in this case, the key can be social security number. In this case, the key can be student ID. Okay. And if we represent such a definition formally, what is a formal and what is informal? Formal means formal dressing. Informal. So when we talk about, when we mention about the formal in computer science, formal means it's a mathematical notation. Okay. Informal means just verbally described. So for example, in this case, a formal definition of the relation or a formal definition of the relational model, meaning is that is a schema. Schema can be represented by the R. R has A1, A2, and AN number of attributes. Informal way of the definition of a schema, definition of the relation is, I said a group of attributes. This is an informal definition, okay, without using mathematics. But here we are going to use mathematical notation. It's very similar as the set theory, set notation, but it's slightly different. You can understand. R is name of a relation, and the A1 through AN is the number of attribute. So for example, customer is the name of a relation, and these 1, 2, 3, 4 are number of attributes. So our goal is to find number of attributes to create the database. Then what can be the key of the attribute the customer? Customer ID can be key attribute. At the time, if this key was not in the data, but intentionally, if you create the customer ID, that is called the artificial key or surrogate key. A lot of time we need such artificial key and surrogate key. I will explain later why we need and what is the benefit, what is the disadvantage of that later. Okay, then at this time, the EF code, name this data as the tuple. So if you look up the dictionary, some of the dictionary do not have the item tuple. Tuple actually used the first time in the database designed by the .EF code. So when you read the technical paper regarding to the data or database, they use the name of tuple instead of the name of data. Okay? So this is the tuple. So each tuple can be represented by the bracket like this. And for example, this is one instance, the 632.895 and so on. So this is the one tuple and another tuple. So what is a relation? Relation is a set of group of such a tuple. Okay? But they should be the same attribute. It's a standardized. Okay? So what time is it? It's 9. Okay, so next class we are going to continue the definition of the relational model, and then I'm going to start again from the what is the domain. Okay. Any questions? Please complete your homework or any assignment on time. Then we will see on the Wednesday. Wednesday we do not have the exercise right. Instead, we will have the AWS, the extra lab on Friday.